Hello and welcome to video R6, our review for our end of course assessment, and today we're going to do a really quick review on polynomials. I think you'll find this to be pretty simple. We just have a few key concepts to review. Big key on doing this on your end of course assessment is graph the function. It almost doesn't matter what you're trying to do with a polynomial function. If you graph it on your calculator, you can probably find the answer to the question. You can find x-intercepts, you can find in behavior, you can find minimums, you can find maximums, you can find y-intercept. We'll do all of those in a minute. But the big key to polynomials is graph the function on your calculator. A few things that you need to remember. X-intercepts are the same as the real roots of a function. If you remember that only real roots give you x-intercepts, that's where it crosses the x-axis. If you have an imaginary root, it doesn't give you an x-intercept. One way that the EOC is really fond of showing this is they're fond of saying f of x is equal to 0. Remember that when that is true, you have a root of the function. If you get an answer of 0 when you substitute any value for x, then it is a root of the function. Also remember that any factor set to 0 is a root of the function, and that's true whether it is real or imaginary. When you set that factor equal to 0, you get a root of the function. Radical and imaginary roots. If you have 2i, or you have the square root of 3. Radical and imaginary roots always occur in, and you got to know what the next word is, conjugate pairs. So if 2i is a root, negative 2i is a root. If 3 plus 4i is a root, 3 minus 4i is a root. If the square root of 7 is a root, negative square root of 7 is a root. And last little fact you need to remember before we do an example, imaginary roots do not intersect the x-axis. Doesn't mean they're not a root, but they do not intersect the x-axis. Alright, so just a general summary of some of the things that you know or need to know about polynomials for the end of course assessment. Let's do an example and look at how to find this stuff. And we're going to do one very complex example and look at how you can get all of this off your calculator. The function f of x is equal to x to the 6th plus 6x to the 5th plus 9x to the 4th minus x squared minus 6x minus 9. If we graph that on our calculator, we get something that looks like this. Well, and I've marked this off in 2s, so please know that. We're looking at 16 up here at this mark. This is 8 right here, so 2, 4, 6, 8. So let's talk about all of the things that we can get from this function. First of all, if we had started with the graph instead of starting with the equation, we would know that this function was of even degree. And the way we would know that is because it goes up on both ends. We would also know that our leading coefficient here was positive. So we not only have an even degree, we have a positive leading coefficient. Now we can tell that from our graph. We can tell that from our equation. If we look at our equation, we have an even degree, positive leading coefficient. We know it goes up on both ends. We can do that backwards. We can look at our graph, and we know it goes up on both ends. Therefore, it is even degree, positive leading coefficient. Things that we might need to find. First of all, you might be asked to find the y-intercept. So if I do second calc value after I have graphed this on my calculator and say x is equal to 0, then I can determine my y-intercept. And my y-intercept here is 0, negative 9, where it crosses the y-axis, and it crosses right here. We've got a y-intercept of 0, negative 9. You can find that always on your calculator once you've graphed it by doing second calc value. Another thing that I'm often asked to find are things like minimums and maximums. If I do second calc maximum, I can find this maximum value right here. Now this is a relative maximum because this is going up from here and it's going up from here. So there is no absolute maximum in this particular function because it goes up forever on both ends. But I have a relative maximum right here. So if I do second calc max on my calculator, it tells me that that maximum value is at negative 2.04 and 15.04. So the relative maximum there is 15.04. I can do the same thing with minimum. I can do second calc minimum, and I get 0.51, negative 11.49 for this point right here. I have a relative minimum value here. That's also the absolute minimum because nowhere in this function does it go any lower than that. I have another relative minimum right here at this point, and that's at the point negative 3, 0. Negative 3, 0. Now, that's also an interesting point because when I look for x-intercepts, I can find them with second calc 0 on my calculator. That negative 3, 0 is also a 0 of the function. So think about what do we know about that particular 0 of the function. This is bouncing off my x-axis here. So we learned something about that when we were talking about polynomials. If you had a bounce off the x-axis, you know that a factor occurs multiple times. So this particular factor has an even multiplicity. We'll come back to that and talk about that in a minute. What are the rest of my zeros? Well, if I calculate the rest of my zeros, I discover that I also have a 0 right here at negative 1, 0. And I have a 0 right here at 1, 0. So second calc 0 will give me those. All right, so each one of these zeros gives me a factor of the polynomial. So I know I have a factor of this polynomial of x plus 3 because I have a 0 at negative 3. I know I have a factor at x plus 1 because negative 1 is a 0. And I know I have a factor of x minus 1 because positive 1 is a 0. I also know that this particular 0 has an even multiplicity, which means I know I have another x plus 3. So either this particular factor has a multiplicity of 2 or it has a multiplicity of 4. How do I know that? I know that because my power here, the degree of my function, is 6. So I know I ought to have 6 zeros or 6 factors. Well, I've only got 4 here. So either this x plus 3 actually occurs 3 times or 4 times, so that it has an even multiplicity and I have a total of 6 factors, or this x plus 1 occurs 3 times, so it has an odd multiplicity, or this x minus 1 occurs 3 times, or this has a multiplicity of 2 with 2 imaginary roots, which is what this particular one is. The other 2 roots in this one are x plus I and x minus I. So those 2 unaccounted for zeros that don't result in an x-intercept may very well be imaginary factors, imaginary zeros. In this case, I had 2 x plus 3's and x plus 1 and x minus 1 as factors, and then imaginary factors of x plus I, x minus I. You could have something that looks very similar to this and have 4x plus 3's and x plus 1 and an x minus 1. Or you could have 2x plus 3's, 3x plus 1s, that gives you an odd multiplicity, so it goes through, and an x minus 1, or 2x plus 3s, and x plus 1, and 3x minus 1s. Odd multiplicity is going to go through, even is going to bounce. If you don't have enough real factors, then you've probably got imaginary factors for the rest of them. That's a quick summary of the stuff that we did with polynomials. Do your review problems for this and then run your little test at the end. Polynomials are sure to show up on your EOC.